to another video with iLearn Engineering. My name is Leslie, and today we're going to look at relational databases, what they are, what they're used for, what they look like, all that kind of stuff. So you may have heard of a database before. You may have used databases before, but maybe you're not sure of what a relational database is versus some other kind of database. So a database is basically a way to store data. Okay, it stores data, and it's kind of most basic iteration. It will store a certain type of data that is called structured data. So we have two types of data. We have structured data, and we have what we call unstructured data. So structured data is data that has a very defined kind of format. So say we wanted to store information on customer transactions, and we have the customer names. We know what format that's going to be in. It's always going to look the same. We have the customer address. Again, same kind of format, always looks the same. We have a list of the products that they've bought. We have the bank details that they've used, and whether they've had the thing sent out or not. So everything is very defined, structured. We know what the format of it is going to be. If the format changes, we get prior warning, and we can then change how we store it. So that's structured data. Very easy to search, very easy to store. Unstructured data is data that is, and it's more of a newer kind of data that we're seeing, as technology changes and our lives change. It doesn't have a definite format. So it could be Word documents, it could be PowerPoints, it could be social media posts, it could be videos, it could be photographs, all those kind of things. So it's data that doesn't have that defined structure that we always know what to expect, and it's easy to store. If we have a lot of Word documents that we need to store, it's hard to store those in a certain way, and it's hard to search through them and all of that. So it's really useful information that companies want to keep to help them, make decisions on what customers like, what customers are doing, maybe what competitors are doing, what people are saying about them on social media, all those kind of things. But it's not as easy to store or search. So we have two types of databases. We have a relational database, and it will store structured data. We then also have another type of database that is a NoSQL database. It's a non-relational database, and it stores unstructured data. You'll be shocked to know. It stores unstructured. So it's set up in a very different way. They're both set up in very different ways, because they store very different things. Now, a non-relational database can also store structured data. They were set up more to store the unstructured data, and that's kind of why they were invented. It used to be that we had very, very structured data all the time, but with the internet, with social media, with forums, with how things are so global and we can buy things over the internet and upload our photos, and everything's changed a lot. So the data that we're storing has also changed a lot, and that's why the non-relational database come into play. But we're going to just look at relational databases for this video. So what is it? So it stores that structured data. It stores it in a very defined way, and it stores it in tables. And the tables have a very defined structure as well. Let me just drag this up. So I do have a little screenshot for you guys. So if you imagine that this is a table, the relation, where's my little pen? The relation of that table is basically the table name. And each table will only store information about one thing. Excuse me. So maybe say we have our own business, and we have we're selling things to customers. So we maybe want a table that will store customer details, name, address, telephone number, whatever. And then we maybe have another table that stores the products that we're selling. And then we have another table that stores details about our staff. And then we have another table that stores the payment details. And then we have another table that stores invoices and things like that. So the table will only store information about one thing. So the relation is what is being stored in that table. And we give the table names a very defined explanation based kind of name. So if I have a table that stores customer details, I would call it customer details. I wouldn't call it table B because that doesn't mean anything to anybody. So say this is a table about customer details. Let's just imagine. So the relation would be something like customer details, and we would write it like this. So we have a small letter at the front, and then the next word would have a capital letter. So that's the kind of case we would write things in. So this is the name of our table now, and we're going to store different things about the customer. So an attribute of that customer is basically a column of data that we're going to store about them. So maybe here we have customer ID, and then in the next one over we have their first name, and again we write it in this kind of defined format. And then the next column we're storing last name, and then the next one maybe we have house number, and so on and so forth. So each attribute is something that we're storing about that customer that we store in a column. And then a tuple is an entire record for that customer. So if I was wanting to store things about myself, maybe my ID would be 2, and then my first name that we're storing would be Leslie, and then my last name would be, I almost can spell, Brady, and then my house number would be number 10, and so on and so forth. So everything about me is stored in a tuple. Every piece of information that they have about me in this particular table would be stored in a tuple. So a tuple is also a row, and it's everything about that particular item that we're storing. So they're the kind of the key concepts behind the table in a relational database. And we're going to have multiple tables. We don't just have one table. We'll have a table about customers, we'll have a table about products, we'll have a table about invoices. If it was, say, for a college, we would have a table of students, lecturers, classes, units taken, exams, assignments handed in, all that kind of thing. We have lots and lots of different tables, and we have to link them together somehow. And we link them together with keys. So we have primary keys and we have foreign keys. I have another couple of screenshots just so you can see. So this is a small relational database here, and it's about students. We're storing information about students. So in this one, we have a students table, and we have student courses, and we have courses. So we're storing information on our students, so their ID and their name, and then we're storing information about the courses, their ID and their name. And then in the student courses table, we have student ID and course ID. So what happens here is that this first column here, ID, that is numeric and auto increment, so it increases by 1 every time. So we have 1, 2, and 3. This is known as a primary key. And that allows us to uniquely identify every single row, every single tuple in that table. And if we look over here at courses, we have also ID. Again, they're unique and they auto increment, so they increase by 1 every time. So this is also our primary key. Sometimes you'll see them written as just PK, like that. That stands for primary key. So in our student courses table, you can see that we now have student ID and course ID, and they relate to the 2 primary keys out of those tables. But in this table, our student courses, this is now what we call a foreign key. The foreign key is a primary key from another table. So here we would call that a foreign key or an FK. You'll see it written both ways. So the primary and foreign key is what allows us to relate the tables together. It's what allows us to have that relationship between the tables. If we didn't have any keys, we didn't have any foreign keys, we didn't have any primary keys, we wouldn't be able to link our tables together. If we didn't have a primary key, it would also be really difficult to find a particular row, because it's feasible that we could have, say there's a student called Sam Winchester in our college, and he's in my class and he's taking databases. I could have two students with the same name taking the same course. That's feasible, right? Okay, they have different addresses and maybe they're taking some other courses that are different, but in the students table maybe they look exactly the same. If we're only storing certain pieces of information about them, like their name. You know, if I had this students table, I could have two Marys, I could have two Leslies, who knows? So the primary key allows us to uniquely identify that tuple, and it allows us to search and uniquely do something with that particular student or that particular, course, invoice, customer, whatever it happens to be. Okay. I also have another table that might give you another little kind of insight. So here we have users, movies, tags, and ratings. So this is, a cinema or something like that kind of database. So in the movies, they have an ID, they have a name, and they have a description. So say they might want to store information about what movie is really good that I like, Beetlejuice, right? So maybe it has an ID of 23, and then it would have a name. I can almost spell. That's not the name of it. And then maybe the description would be some text around the plot, something like that, right? So that's what they're storing in this table. The users, you can see they're storing first name, last name, and email. The tags, they have a tag, so that might be horror, comedy, action, whatever. They have a user ID and movie ID, so they can link them together. And then they have ratings, so that could be 15, 18, PG, whatever it happens to be. And then they also have a user ID and movie ID. So this is a different type of diagram that shows relationships between the different tables. So here we're just listing the table out, and we can see each one has what we call a data type. So we know that the ID here is an integer. In fact, for this table, everything's an integer. If we look at table users, the ID is an integer, but everything else is something called a varchar. That's basically text. So this is a nice way for us to kind of see what this table looks like. And we can see the lines between as well that are denoting the relationship. So in this case, this user ID relates to the user's table. We have what we call here a one-to-many relationship. So I have one user with that ID, but they might appear several times in this tags table. So that's what we mean by one-to-many. So in our table users, ID is the primary key. In our tags table, user ID is a foreign key. And that's the same with the movies table. So we can see here that we have the primary key here of ID, and then it comes through into the tags table as a foreign key. And this is our relationship. Again, that's a one-to-many. This is our relationship between the different tables and how the primary keys and the foreign keys work. So that's the basic foundations, if you like, of a relational database. We are going to have another video that will talk about how we actually query a relational database, how we get information out of it, and what that looks like. So keep an eye out for that video as well. But hopefully you've learned something here. You've learned a bit more about relational databases, and hopefully you find it very interesting. And I'll see you again in another video. Thanks for watching. Bye.